Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In the last class, we already discussed on the pass transistors. Basically, pass transistors suffers from threshold drop when passing the wrong value. That's mean if NMOS transistor or PMOS transistor is used alone, it may need additional circuitry to pull the output to the rail. For example, if we have logic 1, logic 1 is passed very well through PMOS, but poor in NMOS. And if you have logic 0, then it is passed very well in through NMOS, but very poor in PMOS. So therefore, pass transistor does not operate well in nanometer process. So we need fully complementary transmission gates for this purpose, so that both 0 and 1 can be passed very well. Okay. If you look at the NMOS and PMOS, for the transmission gates here, we have that the gate, the NMOS here is in parallel with the PMOS, and if we have a gate of logic 0, then the NMOS will be off, so there's no circuit will be turned off, and no current will be passing through from A to B. But what if we have the gate equal to 1, then the NMOS will be turned on. And what is that GB? GB is the gate bar, meaning if we have 1 for the gate, then the GB will be 0. So both will be turned on, the NMOS and also the PMOS. So for this purpose, the current will be transferred from A to B. So let's say we have a gate of 1, yes, and the G bar will be 0, so both are turned on. Then what if we pass an input of A equal to 0, then we will pass a strong 0 through the NMOS. And if we have an input of A equal to logic 1, then we will pass strong 1 through the PMOS to the output B. Okay, so what are these three symbols here? There are three other ways to draw the symbol for transmission gates, but the easiest way to draw is the first one we had here. Alright, this is a three-state buffer. This is a buffer with a three-state: input A, output Y, and input enable input there. So what three-state buffer will do? It actually produce Z floating when not enabled. So meaning to say, if you look at the enable equal to 0, this one, the Y output here will produce Z output or Z output, okay, regardless of the input we have here, right? But if you have enable equal to 1, then the output will be equal to, it will takes the input value. So it just check on the enable, which is equal to 0, then it will give a floating Z. And we actually need these two condition, the floating point, to save or conserve power in some circuit. And another way to draw the symbol for three-state buffer is this way, right?